Hey everybody, I'm Nick Elledge, one of the co-founders of Data Fleets. Thanks for taking time out of your day to chat about getting privacy enhancing technologies out of the lab and into real production use cases, something that's very near and dear to my heart. And I hope by sharing our experience here at PriCon, we're able to get more and more impact out in the world. So, starting right out of the gate, what are the six things that enterprises really care about when they're evaluating privacy enhancing technologies? I'll get into that, but first you have to understand a little bit about the types of people that you're going to run into when you're trying to either sell or market or otherwise get these into use. Three kinds of people. First are people who have never heard of the technology. So you'll say homomorphic encryption, and they'll look at you like you are speaking a foreign language. The second is that they have heard of it, but they haven't heard good things. So there's some disillusionment. They've heard it impacts the analytics quality. They've heard it's slow, it doesn't scale. Somehow they believe this just isn't going to work. They're skeptical. And the final group are those who are trying it in earnest by themselves in that moment already and are recognizing that it's pretty difficult to implement yourself for the first time. And so with that context, depending on who you're running into, there are six things that they're really focused on. So first is speed. Second is simplicity. Third is the analytics utility. Fourth is multi-party capabilities. Fifth is privacy. And then finally is security. So I'll run through some explanations and examples of what each of these really represent. So first is speed. Speed is fairly straightforward. It's something that you can benchmark with a certain amount of compute power, being able to achieve, this model trained in 17 minutes. And if your result is this model is going to take 3 years to train, then you have a big problem. And certain privacy enhancing technologies, specifically those with encryption, sometimes slow things down a lot. So you have to make sure that the amount of data that you're dealing with is fit for that particular use case. The second is simplicity. So how many extra trainings, extra pieces of process do I have to put into my organization in order to really make this work? The third is utility. Is this going to impact and specifically degrade the quality of my analytics? Am I going to get back garbage results from this, or is it going to be the real results? Fourth, multi-party capabilities. A lot of privacy and private data exchanges involve multiple parties being involved, and not every technology and not every system enables those exchanges to happen end to end. Fifth is the privacy guarantees that you're able to afford. So depending on the situation, how sensitive the data is, how much you trust the actors who are going to be accessing it, you'll have different configurations for privacy. But being able to prove not only mathematically, but legally that you are compliant on privacy regulations is critical. And sixth is security. One area that's pretty critical here, but sometimes uncomfortable to broach, is that 30% of data breaches come from insiders, someone who has a bad intention or was just going through a really rough period and decided to take it out on your organization. And those security breaches can be reduced if you have privacy enhancing technologies in place, if people aren't accessing the real and sensitive underlying data. So being able to prove that you're elevating the game on security above the status quo is a sixth thing that enterprises do care about. So hopefully by sharing that framework gives you a sense of when I'm approaching someone, whether they've never heard of it, whether they've heard bad things, or whether they're trying it now for the first time, you're able to walk through that framework and be able to prove to them where the trade-offs are in your stack. There are no silver bullets. within privacy enhancing technologies. So being able to show them why this is fit for the use case that they want using that framework hopefully is helpful. But that brings me to a second and larger point, which is that the technology is only part of it. A chief analytics officer at a major financial institution shared with us recently that he thinks about three things. First is technology, but second is people, and third is processes. And that's core to his job. Solving the technology problem is only a piece of it. And the example I can share here is federated learning. Being able to ship a model out to where data sets reside without having to aggregate those data sets into a data lake or some other centralized repository, without having to make copies of that sensitive information, have all the redundancies in place, is a paradigm shift. The technology may be ready, but is that company ready for the processes and the people implications that's going to happen to that IT organization within that enterprise? These are the considerations that I think we should be having when we're going to really deploy these, and we want to see impact and value coming out of them. So we've covered the 6 things to be able to benchmark yourself against different personas or people who might be encountering your technology, and then 3 things that analytics officers and IT organizations are thinking about. I think it'd be useful to share 2 use cases that we at Data Fleets are working on, one in federated learning in financial crime, and one in differential privacy with healthcare patient records, maybe illustrate some of the challenges that we've encountered, and maybe you can work with us and help overcome. So the first has to do with federated learning for financial crime. I believe this is an incredible use case. Security collaboration, fraud detection collaboration, the incentives align so beautifully for multiple institutions to share a single model, because none of them can see the full picture. None of them have all the transaction data. None of them are able to see the full elephant, if you will. So the sum is truly greater than the parts. What's the challenge? Well, I believe the biggest challenge in that use case is being able to prove to every single endpoint that their data is being treated in the right way, that it is secure, that it is private, and that they maintain control over it. Now, why is that important? Because those organizations, whether it's banks, asset managers, hedge funds, etc., are worried that their information may be exposed to others. These are competitors of theirs at the end of the day. They also are worried about the regulatory challenges. Are they breaking the law, or are they going to get cracked down on by financial regulators for engaging in this type of fraud detection collaboration? Being able to get stamps of approval from the legal community on those mathematically proven techniques is important, and something that will help move that use case forward. So a second example, differential privacy for patient records. This is not a federated use case. This is just trying to take patient records for healthcare and make them available to academic researchers for hypothesis testing in a differentially private manner. It's a remote execution use case. What are the challenges? Well, there are 2 big ones. First is an education component. What is your privacy budget? What is an epsilon parameter? There are a lot of insider terms that you have to come up to speed on within differential privacy to be able to use it effectively. And the second really is HIPAA certification. So how do we map HIPAA's guidelines around safe harbor and around expert determination to the mathematical guarantees afforded by differential privacy? This is work that's ongoing by a number of communities and scholars, and I believe that the results that are coming out, at least in the last 12 months, have been stellar, but something that would be solved more quickly if we had some sort of gold standard to be able to point to. And one of the final challenges is being able to demonstrate the analytics quality is the same or even better in this use case than having access to the raw data, or in certain circumstances being able to allow access to the raw data under the right conditions. So again, that is absolutely critical to making this use case work. So those are some use cases. Those are a framework for thinking about deploying these for enterprises and how they're being evaluated. I'd love to just close out by sharing a little bit more about my background, how I came into this, and what I'm hoping to be able to achieve out of our work with OpenMined and with data fleets. So a lot of my background was in international development and human rights. And I encountered a number of situations where data privacy kept us from being able to achieve outcomes that we wanted, that we felt like were going to have an impact in the world. So I remember it was almost 10 years ago now, working in a country in East Africa, trying to craft for them a strategy for climate change mitigation, because climate and weather pattern changes dramatically impact the rainfall for their hydropower and obviously for agriculture and for drinking water. What I didn't expect was that historical rainfall patterns over the last 30 years, which we needed to train that model, were sensitive. That country didn't want to expose that they had actually had droughts that they had not publicly announced to the international community and to the press. And we ended up getting only a redacted and partial version of that data set. And I wish that we had some sort of privacy guarantees on that model training to be able to access the full data set. We encountered this again when we were doing labor work for a Middle Eastern government. They wanted to be able to reduce unemployment in their country. A lot of young people were unemployed and struggling, and in order to help, we needed to get access to the labor data set. That included gender, that included the number of migrants and people from international backgrounds within that community. It included the wages of those people. And that was considered too sensitive to give us access to, and in the end ended up making it so we couldn't move forward with that project. Those are two examples of things that I've run into. I'm sure you have your own examples and motivations, but I'm hopeful that we're going to be able to create a world where statistics organizations and economic decisions and international development is able to access those kinds of data sets easily and with the security and privacy guarantees that are afforded by these technologies. Thank you so much to Andrew Trask for allowing us to sponsor this year's conference and allowing us to speak. We look forward to many more years of collaboration. And thank you for taking the time. Please feel free to reach out. We're at Data Fleets on Twitter, and I'm Nick at datafleets.com. Thanks so much. Have a great rest of your conference.